Completing the square is a very useful method for solving quadratic equations. To use this method, we need to understand the square root principle for quadratic equations and the concept of a perfect square trinomial. For the square root principle, let's look at the equation x plus 4 squared equals 5. This equation can be solved by taking the square root of both sides. This gives us x plus 4 equals plus or minus the square root of 5. Subtracting 4 from both sides gives the solutions x equals negative 4 plus or minus the square root of 5. To understand a perfect square trinomial, let's look at x squared plus 8x plus 16, just the expression, not an equation. In this case, we can factor this expression into x plus 4 times x plus 4. We know that we can also express this as x plus 4 squared. What we want to notice here is that this expression, x plus 4 squared, looks just like this expression in the equation that we just did. To show how we can use this using completing the square, let's look at the equation x squared minus 4x minus 14 equals 0. When we go to solve this, we may look to see if we can factor this expression. We can see here that we can't. So we know that this also cannot be written as a perfect square trinomial at this time. To use completing the square, the first step we will do is add 14 to both sides. The next step involves us completing the square. What we are trying to do here is we are trying to add something to both sides of the equation that will make x squared minus 4x plus something into a perfect square trinomial. We can find what to add to both sides by calculating b over 2 squared. Remember that the b comes from a quadratic equation in standard form, ax squared plus bx plus c. So b is the number in front of the x. In this case, that number is negative 4. So we are doing the calculation negative 4 over 2 squared. Negative 4 divided by 2 is negative 2, and negative 2 squared is 4. This tells us that we want to add 4 to both sides of the equation. Now, when we look at the left side of the equation, we can recognize that x squared minus 4x plus 4 can be factored into x minus 2 times x minus 2. We can then write x minus 2 times x minus 2 as x minus 2 squared. This gives us an equation very similar to the one we started with. We can now apply the square root principle by taking the square root of both sides, and we get x minus 2 equals plus or minus the square root of 18. We can add 2 to both sides, and now we just have to simplify this radical. The square root of 18 can be broken into the square root of 9 times the square root of 2. So our final answer is 2 plus or minus 3 square root of 2. We have now solved this equation using the method completing the square. Because we're taking the b term and dividing by 2, this method will work best when the b term is even. However, this can still be used when the b term is not even, or when the coefficient in front of the x squared is not 1. For example, let's look at x squared minus x minus 1 equals 0. We can start with the step of adding 1 to both sides. And now we want to complete the square for x squared minus x. We know that this comes from doing b over 2 squared. In this case, the b term is negative 1. Since -1/2 is already in simplest form, we will just square this to give us 1/4. This means we're adding 1/4 to both sides of the equation. By adding b/2 squared to both sides, we should have already completed the square. This expression may not have familiar factors, but factoring this expression does give x minus 1/2 times x minus 1/2. While that may not be as familiar, an easy way to know what the expression factors into is to look at the number you got before you squared the b/2. This number will always represent what goes in with the x in this parentheses. So because we know that when we did -1/2, that gave us -1/2, we will know that this will be x minus 1/2 squared. On the right side, we have to combine 1 plus 1/4. So we can rewrite 1 as 4/4 to get a common denominator. And now we have x minus 1/2 squared equals 5/4. Applying the square root principle, we have x minus 1/2 equals plus or minus the square root of 5 over the square root of 4. Adding 1/2 to both sides, we have 1/2 plus or minus the square root of 5 over 2. Since these two have a common denominator here, we can combine these into one fraction to be 1 plus or minus the square root of 5 over 2. So, while it would be easier for the b term to have an even value, it can still be done fairly easily with an odd value. Let's now see what happens when we have an equation whose a term is not 1, such as this one. 2x squared minus x minus 2 equals 0. We can keep the same first step of adding 2 to both sides of the equation. However, when completing the square, it is important that the a term be 1 in the expression that you're trying to complete the square for. So we will divide both sides of the equation by the a term, which is 2. This will give us x squared minus 1/2 x equals 1. We can now try to complete the square for the expression we're given. Again, we know that completing the square means we have to do b/2 squared. In this case, b is not only not an even number, but it's a fraction. This means we have to do 1/2, -1/2, divided by 2 squared. This is equivalent to saying -1/2 times 1/2 squared, or -1/4 squared. -1/4 squared is 1/16. So we will add 1/16 to both sides of the equation. Remember, when completing the square here with a fractional b coefficient, you may have to break this calculation down a little bit more. We know that it's b divided by 2 squared. It would be easier when your b already starts out as a fraction to recognize that dividing by 2 is the same thing as multiplying by 1/2. Division is the same thing as multiplying by the reciprocal. This will keep your numbers in a more manageable form. Now, using the trick that we did before, this may have looked complicated. However, we're going to use what we saw before that told us that this will be x, and then this number here is the number that automatically goes in the parentheses with it. So these factors are x minus 1/4 squared. We can see that we would be able to see that this trinomial here factors into x minus 1/4 times x minus 1/4. Where that may not be as familiar of a factoring pattern, we can use this trick of using the b over 2 term that we just calculated. On the right side of the equation, we need to combine these two numbers, 1 plus 1 over 16. So we will rewrite 1 as 16 over 16. So we have x minus 1/4 squared equals 17 over 16. Using the square root principle, we will take the square root of both sides, which gives us x minus 1/4 equals the square root of 17 over the square root of 16. We can add 4 to both sides of the equations, add 1/4 to both sides of the equation, which gives us 1/4 plus or minus the square root of 17 over 4, and then combine the two fractions. So completing the square, while easiest with an a of 1 and a b that is even, can definitely be applied to many other types of equations.